Oh, hey guys, so today I'll be going through MLOE experiment 3 as fast as I can. Like, try to explain, but as fast as I can. So the first question is to write a Python function to read the data from housing.csv. Okay. Um, so first we need to import the necessary libraries. I don't think I need NumPy. Okay. Then what you need to do is you need to download the housing.csv data. Okay. So the hands on machine learning. So ma'am said that it's with the book, right? So it's from the book. If you go to the book and if you type the book and then if you type GitHub, you can get the first link, which is AGERON hands-on ML2. Then go to datasets, then go to housing, then go to housing.csv. If you go here, you can kind of you can download it, but best to view it as a raw file and then save as. It will save as housing.csv. You can save it wherever you want, wherever your working directory is, that's where you save it. Okay. So for me, my working directory is right now. Just give me 1 second. Okay. So my working directory is here in college stuff. So I've saved it in a folder called data.housing data and housing.csv. So if I go to MLOE experiment 3, search how to read CSV file in Python pandas, you can get whatever you can. If you search for that, you'll get that it says pd.read.csv. So just do df, saving it into a data frame, pd.read. I don't know what function I want, so I can just put re and press tab. It will give me all the list of functions which are there which start with re. And then the parameter must be a file path which is as type string. So the path must be, it should be a path which is in the form of a string. The path is actually in the same directory. I have to go, the function should go into data / if housing. Say you don't know the whole spelling, you can just put the first 3 letters or first 2 letters, whichever you remember, and press tab. It will fill the rest of it out. So that is df. Okay. Then what you need to do is you need to go to so this will give us the data frame by itself. Second question is to print the last 3 rows. Now a pandas data frame has a lot of functionality such as df dot, if you can take mean, you can take median, you can take mode, you can take like head. Okay, so df.head, it gives us the, by default, gives us the first 5 rows. Okay, so if I press shift tab over here, you can see that int 5 is the default value, but I can specify whatever number I want. If I put 6, it will give us the first 6 values and so on. Similarly, we want the last 3 rows. So you can Google how to print last 3 rows of pandas data frame. Click on the first link. Look at the answer. Don't forget data frame.tail. df.tail of 10. Okay, so that is what tail does. It gives us the last n rows, and I just put control enter. You can see that it gives 20637, 638, 639. Those 3 indices are being given. Okay, now display the 7th record in the data set. Okay, so I don't know how to do this, so let's just see how to display any record in pandas data frame in Python. Okay, so there are multiple methods to do this. If you just read these answers properly, you will understand that you can use functions such as log, ilog. Okay, but when you're using ilog, it gives us the index location. Since Python is a 0 indexing language, if you want the 7th record, you need to index to the value 6. Okay, now if you use ilog and just put 6, it gives the result as a pandas series. But if you put it in double brackets, it will give us the result as a pandas data frame. Let's say I want the results from the 7th row till 15th row. I put 6 is to 15. I think that's wrong. But if you look at the, I'm sorry, if you look at the data frame, you might get 6 to 15. How to print the 6 to 15 values, you can get it. So that's what iloc does. Okay, so that's question number 3. If you use double bracket, you'll get this data frame type. If you use single bracket, you'll get series type output. Okay. Question number 4. Display the details of districts with population lesser than 500. Okay, so how to filter filter rows in a pandas data frame. Okay. So one way to filter rows in pandas data frame is to use a Boolean expression. Okay. And then filter it out. So if I use this example over here, they're using something called a gapminder dataset, which has the column year. So they're filling it into they're using a Boolean expression equal to 2002. They're checking wherever it's 2002, print it as true. If it is not 2002, it will be false. And it's being saved into this variable called is 2002. When they print out is 2002, it gives us false, false, false. But in some other cases, like some maybe the 10th or 15th or 20th index, it will have true. Okay. So now to filter it out, if you have the same length, let's say is 2002, if let's say this gapminder is 100 rows, is 2002 will also have 100 rows. So if we filter out, let's say 100 false values with 100 false values, it will not return anything. But if we filter like 50 false, 50 true, it will give whatever is only true and you can save it into another variable called gapminder underscore 2002. Okay. So if we're putting it into practice, first we need to make our Boolean expression. Our Boolean expression is to check whichever population has under 500. Population lesser than 500. Okay, this is our Boolean expression. If you press shift enter, you can see that it's true, false, or false. There are these values. Now to filter it all, we need to put it, you need to index it through the rows of the data frame. So if I put df of this Boolean expression true, we will filter it through and we'll get all the places where population is lesser than 500. Okay, so this is 2 steps. First is to create a Boolean expression. Whenever you're filtering, first is to create a Boolean expression, then feed the Boolean expression into the data frame to index it out. Okay, now show total rooms column values. Let's Google how to show single column in pandas data frame. If you Google it and go through the link, you can just see that you can do df.totalrooms, or you can do df in brackets total rooms, but now this should be in string. It's going to give us the same result. Okay, if I run it. Now let's go to question number 6. Count the number of entries with ocean proximity as nearby. This has 2 parts. Filter out the rows where ocean proximity is nearby and count the number of entries. So we know how to do the filtering out part. So let's do that first. Okay. So df of first we need to do df of ocean proximity equal to nearby. Okay. This is our Boolean expression, like population lesser than 500. And then we need to filter it out, means we just need to feed it into our data frame. So it's going to give us all the ones where ocean proximity is nearby. That's 2290 rows. You can stop over here and you can see that it's 2290 rows. The answer is 2290. So we've counted it. But say you want to actually get the output 2290. Okay. There are a few methods how to count the number of rows in pandas data frame. Let's go to the first link, Stack Overflow. There are in the answers, there are three methods: len df.index, df.shape of 0, df.columns of 0, columns dot count. Let's try all three methods, okay? So let's do um, len of this, it gives 2290. Let's do um, shape of 0 dot shape. It should be dot shape, I'm sorry. Dot shape of 02290. Or we can do which gives the count for every row. Okay. Now the reason this works is you guys know how length works. Length counts the length of the data frame, so that you guys know. If I do dot shape, it gives us 2290, 10. So the first value is going to be the number of rows and the second value is the number of columns. So if I want just the number of rows, I can put of 0, it will give us the number of rows. Okay. So that's how the question 6 works. Now question number 7 is displaying the histogram for households field. Okay, so first we need to, this again has two parts, which is first we need to get the household field, which is done by df of households. Then we need to plot the histogram. Let's say you didn't know how to do this, how to plot histogram in Python using matplotlib you can do, or Python pandas series. The reason I'm searching series is because df of household is no longer a data frame. Okay, so if I just do pipe df of households, it gives us a series data type. So you shouldn't search as pandas, you should search series. Then you can see that if you go to this, or if you go to the pandas documentation is always the best. You can see that series.plot.hist or series.hist itself you can directly do. Okay. Here I have used df.households.hist. So this is the basic way and it gives us the basic plot. Okay, for this is more than enough. But since this is not very descriptive of the data set, you can do this. So bins equal to 50. So what it does is it increases the number of bins. This has a default of 5 bins: 1, 2, 3, 4, 5. With 5 bins, we can't tell anything other than the fact that it's left skewed, right skewed. Sorry. Okay, but over here, if I put bins equal to 50 and figure size 12,6, we can see that it's a big plot. Another way to do it is using matplotlib. First you set the figure size as 12,6, then plt.hist, first the array values, then the number of bins you want, then the edge color, and then if you put grid, it will give us the grid. Okay, so that's question number 7. Okay, all you need to do is just Google how to do it, and I'm 90% sure you'll get the answer. Okay, now question number 8, display the columns available in the data set. Okay, if you search how to display the columns, you can see that you can just do df.columns. You'll get all the columns. If you want to display it neatly, for call and df.columns, print call. This is the code which is there online. You can just search for it, but try to understand it. What it's doing is it's going through each element of the list df.columns and it's printing it out. So longitude, latitude, house, median, age, everything. Now coming to the last but one question, display the number of rows and columns. We have already discussed it. We have seen that shape gives us the number of rows and columns. If we just do df.shape, it will give us 20640 or 10. Now finally our data set, final question is to do pre-processing and linear regression. Okay, let's get this going. Just give me 1 second. Okay, it's only been 15 minutes, so I guess it's fine. So we can take another 10 minutes or 15 minutes to explain this. Cool. The data frame needs to what the point of using data is to predict it, or the point of having data is to derive inferences from it or to predict future values. Okay, so that's what we are going to be doing now. We are going to build our first machine learning model. We're going to predict the median housing value. Build the linear regression model for prediction of median house value. Okay. So if we do, so there are a few steps involved. Okay. First, pre-processing. Okay, in which we need to do a few things. Um, First thing would be to see that you see this ocean proximity, right? It's written as near bay, inland, and all that. But when you do linear regression or something, the equation will be y equal to m1x plus m2x2, m1x1, m1x, m1x1, m2x2, m3x3. Okay, and so on. You can see that over here we have ocean proximity will be an ninth one. So the x value, you can't say, like, you've never had professor come to you and ask you to solve a linear equation y equal to mx plus c and put x as near bay and plot a graph. You can't do that. So what you do instead is replace near bay, inland, and everything with numbers, and then do x1, x2, x3, so that you can find the coefficient for it, the m value with respect to that one median value. I'm sorry, that one x value. So first thing would be to replace string categories into numbers. Now the second one is, since linear regression doesn't handle missing values well, generally data doesn't come clean to us. This kind of data never occurs. You'll get like in the form of forms, or you'll get in the form of surveys. You need to convert the dirty data into clean, dirty unstructured data into clean structured data frames, and you need to make sure none of the values are missing, because if there's an empty value, it won't be zero. Empty value means there's nothing existing over there. So the machine learning model will go mad and be like, what the heck, there's nothing existing over there, how do I build a model? So those missing values generally come up like whenever you fill a form, they'll say it's something optional, you will not fill it, right? So they have to fill those on their own. They assume various numbers or various values and then fill it with that. Okay, so okay, so these are called central values, I think, are called are measures of central tendency. Perfect. So they use values such as mean, median, mode, which are values measures of central tendency, to replace those values and missing values. Okay. So the second one would be to replace missing values with measures of central tendency. Now this is the first part. The second part is machine learning. Here, build the model. First we need to split the data frame. Split the data frame into, actually that will come in pre-processing itself, forgive me. Then we need to split the data frame into train and test. Okay, now in machine learning, we first train the machine learning model, then we test it, then we evaluate using metrics. Okay, wait a minute. Okay, so we need to do this. First, let's do the first part, replacing the string categories into numbers. Okay, the only string value is ocean proximity. So ocean underscore proximity is equal to df of ocean underscore. Okay, the reason I'm doing this is because there are many methods. First, I will show you how these methods work on a separate variable. Instead of changing it directly in the data frame, I'll show how it works on a separate variable. Then we'll change it directly in the data frame. Okay, so this is ocean proximity. It has near bay, inland, and all of that. If we see the unique values, there are 5 unique values: near bay, lesser than 1 hour, inland, ocean, near ocean, and island. Okay. Uh, Now there are methods how to convert string column to int in Python categorical data. Just search for it here. Okay. Another better way to do it is label label encoding. Instead of going directly over here, you can just search label encoder Python. Then go to sklearn.tree processing. Always remember the docs are the best place to really understand what's happening. Okay, so these are two methods that are there. You can search for it, you can convert it into categorical data and everything. Okay, now first method is called cat.codes, but if I just press shift enter now, it will give me an error called attribute error. Use .cat.codes only with the category d type. Over here our d type is an object, so to convert it into categorical d type, so you can do it as pd.series of df comma d type equal to category. Now if I press shift enter, it is d type category. If I see the unique values, it will again say that there are 5 categories. Now what cat.codes does is it takes each category in this order, gives it a random ass number, and replaces, it sees what all categories are there. If there are 5, it will do 0, 1, 2, 3, 4. It will take these 5 numbers and replace it accordingly. Okay, if you see cat.codes.unique, there are only 5 values: 0, 1, 2, 3, 4. Okay, this is one method. I would not recommend this because every time you need to convert it already into a category data type and then do cat.codes. Another method is called sklearn.preprocessing label encoder. Over here, just go over here and you read the examples, you'll understand what's happening. Okay, you read the examples, you'll understand what's happening. But the first line would be to import the label encoder function. Then I have saved the function into a variable called le. Now label encoded will be my output variable. So over here, in case let's say I didn't do this cat.codes and I didn't do this ocean proximity, it will give me the same output, but it's not been saved into anything called cat.codes. The reason I did this cat.codes is because it gets saved into a variable. Similarly, this output variable label encoded will be the output of le.fit_transform. So fit_transform converts this ocean proximity from the string data type into numerical categorical data type. Okay, so ocean proximity, you can see that if I press shift enter, label encoded, it takes more time because it's not already categories, it's in string type, so it converts it one by one and figures it out. So if you see, compare little, you see the 333111, it's similar, it's extremely similar. So I'm going to be using this label encoder thing. So this is how it works on this ocean proximity. Now what we need to do is we need to do our thing, replace it into numbers in the main data frame. Okay, so first two lines are the same. From sklearn.preprocessing import label encoder, we have imported label encoder. Then df of ocean proximity is equal to, so you see this label encoded output, right? The output of this will be saved into this. So we want it to be saved into our ocean proximity column. So df of ocean proximity, in that column we want it to be replaced. le.fit.transform df of ocean proximity. This ocean proximity is basically this only. Remember, we just copied it over there. So that's that. So it's completely same. All we've done is changed where our output variable is being saved. If you press shift enter, you can see that ocean proximity is now 333111 and it's been converted. Okay, now coming to column, now this is the first part has been completed. Okay, so let's delete it. Now our second part. replace missing values with measures of central tendency. So that's our second part. So first we need to check whether if there are any missing values. How to check how many rows have missing values in pandas data frame. Okay, count NA and values, count NA not missing values. You go through all of these, you read every answer, you see which method works best for you. You go for this Geeks for Geeks article also, it will be there. What you do is, there's a function called df dot, remember how I said mean, median, head, all that? So df dot is NA. So what it does is, it goes through each and every value, checks if it is missing or not, and if it is missing, it will replace it with true. If it has some value, it will replace it as false. So if I just print it out for you, you can see that it's all false, 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 false. Many of these values are not like there are values, but some in the middle between 4 and 20,000, there will be some missing values. Now, how do we know the total number of missing values? You see that it's in false and true, right? What you can do is, if you do arithmetic operations on true plus true, you get 2. Okay, so if I just, you get 4. But if I do plus false, it doesn't make a difference. Another plus false, it doesn't make a difference. So to get the total number, we need to just see where all it comes true and add it. Okay, for that you can use a for loop and go through it, but again, pandas has a lot of functionality. There is a function called dot sum. Now if we press shift enter, we get the sum wherever. So this one has all false, so when you add false, 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 you'll get 0. Over here also 0, over here also 0. But in total bedrooms, if you add everything, you'll get 207. Okay, you'll get 207. Okay, similarly, in population, that means there are 207 missing values. Okay, now I want to replace this with one of my, so we have seen how many missing values are there. Okay, so the second step is also there. Second step, first part is done. Replace missing value, see what all missing values are there. Now we have to replace it with measures of central tendency. I have used mean. Okay, so what you can search is, how to get mean of column in pandas. You will see that dot mean will be the function. Okay, yeah, pandas data frame dot mean. So this pandas data frame dot mean, if I just do it, df dot total bedroom dot mean, it gives me 537.87. okay, I want to save this into a variable called main bedrooms. I'm doing this int because I want to round it off. You can't have 0.8 of a bedroom, you need to have whole numbers of bedrooms. So I have rounded it down. Okay, you can do roof or you can round it up and all that. So I've rounded it down, it doesn't make a difference. Okay, so now df of total bedrooms. Now what we want to do is, we have this mean bedrooms value. How to fill NA values and pandas with a single value. That's what I have searched, and you can see that pandas.dataframe.fill NA. You can also use pandas.series.fill NA. Okay, so that's what I'll also be using. So this panda df.total bedrooms is our series dot fill NA. Okay, dot fill NA. What happens is, if I press shift tab, you can see the whatever the function does, the docstring of the function. First thing is value, second is method, then axis, then in place, then limit, then downcast, all of this. If you read the what each parameter does, you'll understand what you need to do. Okay, so obviously value means we want to see where, like, value is what value you want to replace it with. Now what is this in place equal to true? Okay, so let me just take this part out. I push shift enter, this is the output. But again, if I put df.isNA.sum, I'm still getting NA values in my total bedrooms. Okay, so if I want to reflect it back over here, I need to replace this this pandas series into the df dot total bedrooms, similar as to what we did over here. Df quotient proximity equal to, we want to replace it back there. We want to replace this into this output into our variable. So there are two methods, which is df of total bedrooms equal to this. This is one method, but people have seen that many people want to replace it, so they have used something called in place equal to true. Okay, so this is another parameter where in its own place, like in the data frame itself, if it is true, it will make the changes. Now this won't give us an output, but if I check for sums now, there check for NA value and see the sum, there are no NA values. So now we can strike out the second part also. Now the third part, splitting the data frame into train and test. Search how to split data frame into train and test. Go through these links. Okay, this is one thing, but the problem with towards data science is you need to upgrade it and read it. You don't do that, like it's a pain. Okay, but if you go to stack, you can see this answer over here. Scikit-learn's train test split is a good one. It will split both NumPy arrays as data frames. So the syntax is from scikit-learn model selection, import train test split, train comma test, train test split, df train size equal test size equal to 0.2. Let's go over here. See that the first parameter is star arrays. So you need to make sure that it's a sequence of indexables with the same length or shape. Okay, which means they should have the same number of rows. Okay, the arrays which you put should have same number of rows. You can put like 15 arrays. You can put like x1, y1, x2, y2, x3, y3. You can put all of those, but all of them should have the same length. Okay, they should have the same length. Then the test or train size you need to mention. What random state is this function, it samples out a few rows from the data frame randomly. Okay, so you might not get the same results every time, but if you put random state as one number 1 2 3, it will always take out the values the same way. It will shuffle it in the same way. Okay, now the thing is, over here if you see, he has taken train comma test is equal to train test split of df test size equal to 0.2. Okay, so for this output, for each array you'll need to have two outputs. Okay, train and test. So for each array you give, so if I have df1, df2, df3, I need to put 3 pairs of train and test in that order, train and test. Okay, so in our question over here, we need to predict the median house value. So this is our y, and we need to predict it using our x variables, which are our attributes, which is ocean proximity, total number of bedrooms, latitude, longitude, all that. Okay, so we need to save our median house value from the data frame into this variable called y. Then we need to so that is going to be our target variable or our label. Okay, so this is our target variable which we need to predict. Now for attributes, we need to use x equal to df dot drop columns equal to median house value. Okay, so columns equal to median house value. This means that, see, if we all in our attributes, if we already have median house value, it doesn't make sense. If we have median house value already, there's no point in predicting if you have all the values. So you need to act like you don't have those median house values. Okay, you need to act like that. So that's why I have dropped the median house value and have saved it into x. Okay, now splitting the data sets. Remember the syntax which we saw from sklearn model selection, import train test split. Okay, so first in our train test split, the first array is x, that data frame with 20,000 rows. The second array is y, which is the array Panda series with 20,000 rows. Then train size is 0.8 as mentioned in the question. Now for x, our first output should be x train x test. Then for y, we have y train y test. Okay, now if I press shift enter, it runs perfectly. If I see x dot shape, y dot shape, they are 20,000, 6,000 and 40. let's say we have an error of let's say I take the values from 4 to 17. If I press shift enter, it gives a value error. The input variables with inconsistent numbers of samples. Okay, say you don't know what this error means, just copy it, just select it and search it, and then go. The train test split error. It knows that it's a train test split error. Found input value is inconsistent. If you go over here or over here and you'll read about it, you'll understand what the error is. You don't copy this entire thing. Only copy this value error last one. Okay. So this means that our shape is not the same. If I do X shape and Y shape, you'll see that Y is only 13 values, but X is 20,000 values. The reason being, it selects the exact indices. So let's say it's selecting the 4th row from X, it'll into train, and the 5th row from X into test. It will make sure that it selects the 4th value from Y into train, Y train, and 5th value in Y as Y test. Okay, that's why it needs to have the same length, because like if it does it randomly for X and Y, then it doesn't make sense, right? Like then X train will not be predicting our correct label. The label will not be matching in the same row. So whichever index it takes over here, it needs to select the same index over here. Okay, if you do this, you get it. And then if you see X train shape, Y X test shape, Y train shape, Y test shape, and you'll see that it's 80% or 20% respectively. Okay, so now our data pre-processing is over. Okay, so data pre-processing is done. Now our machine learning. We need to train the machine learning model, we need to test it and evaluate the metrics. So for training it, just search from sklearn how to get linear regression model. So from sklearn.linear model, import linear regression, linear regressor equal to linear regression. So it's very similar to a label encoder code. Remember, we've done sklearn dot pre-processing, import label encoder, LE equal to label encoder. It's like that. Okay, now what we're doing is we're training it in this line. Line number 3 is training it. So what x.fit does is it finds those m1, m2, m3 values for x1, x2, x3. Okay, then ypred linear regression. So and it finds those values and it now saves them. This linear regressive model is now has now remembered these values completely. Okay, so if x1 equal like for so the equation, it now has an equation in its mind. It has an equation that says my output is equal to m1 times x1, or the column 1 values x1 plus m2 times x2, like that. It has it saved in its mind. Okay, now this function called predict, what it does is we've taken this x test, right? So we've taken this test and we're predicting what will be the output for each row of test values. So there are nine values for each row. So what it does is m1 x1 m2 x2 till m9 x9, it will predict it by using what it's learned from this training and save it into our predicted output. Okay, so if I press shift enter here and if I see y underscore pred, it is an array with all the values which it has predicted using this x test and linear regression. Now to evaluate, we know that this is the prediction, but we need to see how good it is with respect to our real values. Okay, so for this we use evaluation metrics. For classification, the evaluation metrics are different, and for regression, the evaluation metrics are different. So for classification, we see something called a confusion matrix. Now this is our predicted ones. Okay, so the number of predicted and the actual values. So what it does is it takes an intersection. How many of these predicted, how many has this machine learning model predicted to be positive is actually positive, is called as true positive. How many it has predicted to be positive but is actually negative is called false positive. How many it is predicted to be negative and is actually positive is false negative, and predicted to be negative and is actually negative is true negative. We need to maximize these two green, minimize these two red. Okay. Similarly for regression, we have a lot of functions, a lot of evaluation metrics called MSE, RMSE, root mean squared error. Okay, so what it does is it finds out how far away is our fitted line from the true values. It takes the difference from our predicted value. It takes the difference between our predicted value and our actual value, squares it, does it for every point. We have 20,000 points, right? Or in our test, actually, we have 4,000, I think. So for all 4,000 values, it adds each square, divides it by n, takes the average of those squares, sum of squares, and then takes the root out of it. So this gives us the RMSE. Similarly, MSE is calculated, then RMSE is calculated. So just search how to get mean absolute error, mean squared error. What you'll get is from import sklearn.metrics as metrics. It's an alias metrics like pandas as PD. In metrics, there is function called mean absolute error, mean squared error, R2 score, and all that. Okay. So now if I just see this mean absolute error, 1 second. You see that NP is not defined over here. That means I haven't even called numpy till now. But let's say I run this. Okay. If you press shift tab, you see that the two parameters are y true and y prediction, which is our y test and y prediction. Similarly over here for mean squared error, y true and y prediction. And for R2 score also y true and y prediction. So it predicts it all. R squared is kind of like accuracy. So it tells how accurate it is, 0.6284. So we have like an 60 percentage this thing accuracy. Okay, so similarly if you see RMSE and MAE, you might think these are big values like 69,000 and everything, but what it is actually it's seeing how far away it is from the actual value. So if we see y underscore test comma y underscore print, let's see how it prints. Okay, so you see that our value is 13940, but it's predicted as 135200, 16252, but it's predicted as 307. Okay, so 12414, 68200, like that it's predicted it. But if you see the differences, if you see the numbers themselves, they are in orders of hundreds of thousands. Okay, so it is fine, kind of fine. It's not that good actually, but it's kind of fine that it's in tens of thousands. Okay, so you can do RMSE divided by y. So we're trying to see how it is from the mean. You see that it's 33%. Okay, so that's it with respect to 33%. Like that's how much error we're getting. Okay, so that is it with respect to our MLOE experiment 3.